Okay, I think I figured out the problem why it blows the fuse. It needs to have a 10K resistor from the signal generator to that pin right there, which would be number 2 pin of the 4422 gate driver. And this needs to go over to ground, the 10K resistor from this pin to this pin. And this works like a pull-down resistor that you would put across the MOSFET. If you did not have a driver chip, what happens is the MOSFET just kind of stays on for a while and finally turns off because there's a little capacitor in there, and you need to have a 10K resistor to drain that capacitor out. So if you just had a MOSFET with no driver chip, you better have a 10K resistor from here to here, from the source to the gate. And I put them here anyways as kind of redundant feature, just in case, just to make sure it's going to turn off, but it's really not needed. But where it is needed, it's called a pull-down resistor, is on the chip from the signal coming from the signal generator into number 2, which is right here. And I need to have a resistor from here to the ground. So the 4422 MOSFET gate driver chip needs to have a pull-down resistor on it. And it doesn't have one. So it just sticks on, sticks closed. So when you send all this power into this circuit, it's supposed to be getting clipped at 24 kilohertz really fast, so that you don't have this huge amp drain, and it turns off so fast that the current really doesn't make it through before it turns off, or it just happens to make it right through. And then you also need the 24 kilohertz because you want to have the primary coil here getting an AC sort of signal, but this will actually be DC with a collapsing field, which is even better. And if you don't have that, it's just going to be nothing being induced into the spiral flat coils. Anyways, getting to it, I made some copies of what I'm doing right here. I got one right here. So first of all, I got a meter in ohms, 200 ohms, so when I touch these, you'll see right away here it's not touched. So basic, set a meter at 200 ohms, and I'm going to put that between the ground clip, which is the source, ground pin, and the drain, the middle one. So when I put this here, when I put this ohm meter across the drain and the source like this, when it turns on, when the MOSFET turns on, you'll see this have like 0.4 ohms or whatever it'll be. So let's plug it in like real life. I have a ground wire here, the ground which goes to the across those pins, and then it goes off to the source up here. So the ground's hooked up, common ground, might as well call it. And now I'm going to hook up the power input to the chip, Okay. Sorry. Okay, power input being hooked up. Power input hooked up. Look! This switch is now closed. That's not correct. It's a closed switch. You don't want it like that. But now, here's the 10K resistor right here. It's connected to ground. So if I take this white wire and put it on the yellow wire, which is the pin 2, the signal source, which is like what the signal generator would be popping out every 24 kilohertz, whatever you set it at. Now I have this resistor hooked between this pin here and ground. And now it does not switch on. It does not switch on. So this is open. That's what you want. You don't want anything happening. Now, let's imitate it getting a signal pulse from the signal generator. So I'm going to take this white wire here coming off the positive, and when I touch this yellow wire, which is the signal source, it's going to receive 12 volts into there, which would be like what comes off the signal generator. So when I touch this right here, when I touch this, it's going to turn on. There, it turned on. When I remove it, it turns off. Turns on, turns off. That's the way it's supposed to be. But it's because I don't have that 10K resistor, that 10K pull down resistor on the driver chip, the MOSFET is just stuck closed. So it's just like sending all this power, 120 volts, just straight into this coil over here, which is maybe 1 ohm. I can measure what it is. One moment. I'll measure it later. So anyway, so I think I fixed it. So I'm going to put it back together. I bet you this MOSFET's blown. I'll check that out. I have 2 of them already ready to go because I figured I'd be blowing some up. And actually 3 more ready to go. So I think that's it. And if it's not it, it's also that I should have maybe not send in 110 volts. And I ordered a thermal resistor, NTC thermal resistor, like I think Gabriel and Oli both suggested. And when it's cold, it doesn't let hardly any current through, and then when it warms up, it lets current through. And it's kind of a protecting circuit, so you don't just get gobs of current going in when you plug it in. And I ordered one of those, should be here in a few days. And I have some light bulbs. I'm going to throw these light bulbs in series 2 as a way to cut down the current going in. So I'm pretty confident this is going to work, almost confident. So that's what it is. You need a 10K resistor from the number 2 pin to ground. You need a pull down resistor, not over the MOSFET, but before that over the driver chip. So, wish me luck. Thanks everybody for helping out. Okay, thanks for watching.